Hello, I'm Monica McGill, and together with Adrienne Decker, we present our work on the construction of a taxonomy for tools, languages, and environments across computing education, with a focus on primary and secondary education. We extend our thanks to the National Science Foundation for their support of our work. The number of tools, languages, and environments, or TLEs, as I'll refer to them the rest of this presentation, for teaching K-12 computing education are rapidly growing. Yet, how we refer to TLEs with similar characteristics has not been defined in a systematic way. The few classifiers in use, for example tangible computing or block-based systems, have also not been examined closely to know if they consider future expansion and adaptability as the field changes. Taxonomies can provide a way to identify affordances and the advantages and disadvantages of TLEs. A taxonomy can also be used to assess whether a particular TLE is suitable to a specific teaching scenario and can be of use when evaluating and comparing TLEs. They can also be used to direct the design of future digital systems by pinpointing gaps that could potentially be met by new or enhanced systems. In a 2005 article, Kelleher and Pausch gave reasons for building a taxonomy of programming environments and languages. Their work was rooted in their desire to identify the sociological factors that prevent students from learning programming. Their efforts were made to identify which TLEs addressed barriers to learning, including mechanical barriers that place unnecessary cognitive load on learners, as well as the gaps in these systems. In 2019, Malmi, Uting, and Co. discussed several classifications of tools, noting the need for structure in this area and providing their own groupings and definitions of tools. Finally, according to Barkey, 1988, taxonomies enable the development of information system research databases with high levels of user performance characteristics. Our primary motivators for undertaking this research study is to enable the structuring of data using agreed-upon keywords within a large data set for computer science education researchers at csedresearch.org and to update older taxonomies to reflect modern TLEs currently infiltrating primary and secondary education. Our work is part of larger work similar to Kelleher and Pausch's work and reflects our efforts to determine where the gaps are in meeting the needs of the community working to promote effective CS learning across K-12 education. The full methodology can be found in the paper. We note that the methodology we follow Whitaker and Breininger's 2008 framework. For this particular article, we focus on identifying the concepts, determining requirements, and developing a draft taxonomy. We used a thorough systematic literature review to identify concepts, and we created the new taxonomy from this review. Future work is already underway to review the taxonomy with users and subject matter experts, refine it, apply it to content, and manage and maintain it. For the remainder of this talk, we present the new taxonomy. We will not be discussing the details of the systematic literature review due to the many technical details that it entails, and we refer you to our paper for those details. The new taxonomy consists of two distinct components, the engagement and empowerment medium, which is the medium in which we teach computing concepts and programming, and the digital programming environment dimensions. Combined, these make up how we define a TLE system. Let's look first at the engagement and empowerment medium. For non-programming environments, there are two, those that are specific to computer science and computational thinking, and those that are not. For programming environments, we have general-purpose device simulation, digital media, data manipulation, smart blocks, visualization of computing processes, and finite state machines. I'll define each of these in a moment. However, I'd like to mention what you may already be thinking. A programming environment can fall into one or more of these categories. The non-programming environments can be designated as CS and computational thinking specific, and TLEs can be further grouped into digital and non-digital. Digital CSCT specific non-programming environments may be NOA robots, e-textiles, and Raspberry Pi. Non-digital may be board games like Potato Pirates, Robot Turtles, or other unplugged activities. The non-programming environments can also be designated as those that are not specific to CS or computational thinking, but that can still be used to teach computing. Digital, for example, may include something like the New York Times Mapping America, Google Drive, or even YouTube. Examples of non-digital, non-computing specific include physical manipulatives like barrel of monkeys, beads, buttons, and even candies. The engagement and empowerment medium also has within it programming environments. Through our systematic literature review, we uncovered 8 unique categories, 4 shown here and 4 on the next slide. Examples are also provided where we could find them, and more examples are in our paper. Where we could not find an example, these could be created in the future. These are designated with a question mark. For each category, we recognize that different types of TLEs can be defined: block-based symbolic, block-based text, hybrid, typically a block-based text and text-based, and then text-based. General purpose is a system that provides the capability for students to generally create any type of program. Examples of block-based are Scratch Junior, block-based text is Scratch, hybrid is pencil code, and text-based is Eclipse. Device TLEs provide the capability for students to create programs that target a specific device or system. Examples of block-based are Lego Mindstorms, block-based text is MIT App Inventor, and text-based is Arduino. Simulation TLEs provide the capability for the student to program a simulation or program within a microworld environment. Examples of block-based are Lightbot, block-based text is Turtle Art, hybrid is Alice, and text-based is Carol the Robot. Digital media TLEs provide the capability for the student to produce media. Examples of block-based are Kodu Game Lab, block-based text is Agent Sheets, text-based is EarSketch. Data manipulation are TLEs that provide the capability for students to manipulate data computationally, such as in data science. Examples of block-based text is Tableau, and text-based is R. Physical smart blocks provide the capability for students to create programs using a programming interface by assembling physical elements. Examples of block-based are Bbot, and block-based text is Kibbo. We could not envision a physical smart block that would be text-based at this time. Visualization of computing processes provide the capability for students to create visualizations of computing processes or algorithms. One example of a text-based system is Jelliot. Finally, finite state machine TLEs provide the capability for students to create finite state machines as computational engines. One example of block-based text is JFast. That concludes the engagement and empowerment medium. Next, we turn our attention to digital programming environment dimensions. These consist of the dimensions of the digital environments that sit orthogonally to the engagement empowerment medium. We categorized 5 such dimensions from the content of our systematic literature review. The automated assessment and submission dimension provides the ability to submit and give feedback and score or grade programs. An example of this is WebCat. Gamified systems provide gamified elements to the learning process, for example, points, badges, and leaderboards. An example of this is Gidget. Integrated development environments provide programming languages, code editing, compilation, debugging, and runtime diagnostics. An example of this is Eclipse. Teaching systems, according to Kelleher and Pausch, are simple programming tools that provide novice programmers with exposure to some of the fundamental aspects of the programming process. An example of this is the Kodu Game Lab. And sandbox systems provide open-ended spaces for exploration and learning. An example of this is Minecraft. In this presentation, we are unable to provide a thorough discussion in the context of past researchers. However, we acknowledge here the authors of the research work that were included in our systematic literature review. We refer you to our paper for more details. In conclusion, our work continues on the taxonomy. Future work is already underway to review the taxonomy with users and subject matter experts, refine it, apply it to content, and manage and maintain it. We recognize here and credit the images in our presentation. Thank you for listening to our talk on our construction of a taxonomy for tools, languages, and environments across computing education.